Hi everybody, today we're looking at the area between two curves. So what that means is if I've got some function g of x in red and f of x in blue, and they intersect at points a and b, how do I find the area between them? And so the area is the integral from a to b, so these are the x values of the points of intersection of g of x, take f of x. And so it's the upper function subtract the lower function. So to be able to get the area between any two functions, it's always going to have to be the upper function, take the lower function. So if we look at some examples of this, first of all, we're going to have a tangent, and then we're going to find the area between the curve and the tangent. So here we're going to find the equation of the tangent. So start by finding the derivative. So dy on dx is equal to 3x squared take 2. So it's when x equals 1. Therefore, when x equals 1, it's going to be 3 times 1 squared take 2. So then dy on dx just equals 1 as well. And then we also need the point of contact. So when x equals 1, the function is just going to be 1 cubed take 2 by 1. So it's 1 take 2, so it's minus 1. So therefore, the equation of the tangent, and there's many ways you could do this. This is the way I do it, but you're free to use whatever method you would use. So I take this idea of the slope being 1 on 1. So it's 1x take 1y. So that's the coefficient of x. It's the opposite sign to what we've got here. So the plus becomes a minus, and then it's 1y. So that's the coefficient of y is equal to 1 times 1 take 1 times minus 1. So it becomes x take y is equal to 1 plus 1. So x take y is equal to 2, or y is equal to x take 2. So that's the equation of the tangent. So we've got to find where it cuts the curve. Well, y equals x cubed take 2x, and y equals x take 2. So we want to find where these y coordinates are the same, because then that means that it will cut the curve at that point. So x cubed take 2x equals x take 2, so we get x cubed take 3x plus 2 equals 0. And then if we solve this, we get x is equal to 1, 1, and minus 2. So the single root is where it cuts the curve. The double root is where it touches the curve, so that's where the tangent is formed, and then the single root is where it cuts the curve. If you want something similar to compare that against, so when quadratics touch the x-axis, we get a double root at that point. When they cut the x-axis, we get a single root. So it's the same idea here, where we get a double root is where the tangent touches the curve, where we get a single root is where it cuts the curve. So if I draw a picture of this, it looks something like that. 1's there, so that's where my tangent's formed. So if I draw my tangent, then it cuts again at minus 2. So that's x equals 1, and this is x equals minus 2. So we're looking for this area in here, and we can see that the cubic is the greater function. So the area is a higher function, so the area is going to be the integral from minus 2 up to 1 of x cubed take 2x, take away, and it's useful to use brackets here, so we get it right. So my other function is x take 2, so that's a tangent, and then I've got to integrate this. So minus 2 up to 1, let's just simplify it first. So it's x cubed take 3x plus 2. Under integration, this will become x to the 4 on 4, take 3x squared on 2 plus 2x, going from minus 2 to 1. So then it's going to be 1 to the 4, which is just 1, so a quarter, take 1 squared is just 1, so it'll be 3 on 2 plus 2 by 1, which is just 1. So that's the value of my integrated function at 1, and then from that I'm taking away minus 2 to the power of 4 all over 4, take 3 to the minus 2 squared on 2 plus 2 times minus 2. And so then if I evaluate all that, 27 on 4 units squared. Okay, with the next one, I've got a surge and a logistic, and what I'm going to do here is demonstrate how we use the calculator. So I'm just going to get that set up. So in this case, there is no need to do it algebraically because it doesn't ask for the exact points of intersection. So I'm just going to go here and I'm going to go Shift G solve, and F5 gives us intersect. So the first one is 0.00048 and 0.187. So I'm just recording it to 3 significant figures. So it's 0.0448 and 0.187. That's 1 point. And then if I jump back to my calculator, if I just press to go sideways, I get the second one, which is 0.446 and 0.374. So I need the area between the two functions and the vertical lines x equals 0 and x equals 1. So I've just got the line here. So this is, or the graph here. So this is x equals 0 and this is x equals 1. So I'll set that up on my calculator. So I want the area from here through there and all the way across to there. So I want all of that area. Now, if I'm going to use that, there are a couple of options. Firstly, I can do, so the way to do this using an integral expression, and remember it's always the idea of the upper function take the lower. So the integral expression would be the integral, and I'm going to call the red one, now the red one is my logistic, so I'm going to call that f of x, and the, no, that was called g of x. So the red one is g of x, and the blue one is f of x. So the integral expression would be from 0 to the first intersection point, so 0.448. And the red one's the upper one, so it's g of x, take f of x. That gives me that little bit in there. So I'll color that in green. And so then green relates to this section. Okay, now for the next bit, it's f of x that's greater. So it's going to be plus the integral from the two intersection points, so 0.448 and 446 of f of x, take g of x. So this bit I'm going to color in blue. And then it's plus, finally, the integral. Now this is where g of x is greater again. So we're going from 0.446 up to 1 of g of x, take f of x. That's how we could do this using an integral expression, but there's a couple of other ways as well. Now obviously that's pretty tedious to put into our calculator. So there's a calculator way, so I'm going to go calculator part 1, and in this we use the mixed idea, or the mixed function on our calculator. So if I jump back to my calculator, we go Shift F5 for G-solve, then we go across by F6, and we go to this one down here, so that's at F3, and we can just put in a basic integral, a root, an intersect, or a mixed. So we'll go F4 for mixed. Now, mixed lets you set the function anywhere. So it's going to be 0. We're going to start at 0, and we're going to go to 1. Now, what the mixed function does is it says, okay, well, we know that we want the area between the two functions. It assumes that. And it says, well, we don't necessarily just want the integral, but we want the area. And so the area in this case is 0.179. So when it's this little bit here that's colored in green, it's 0.179. But it also gives you the integral as well. So it gives you both. In this case, we want the integral. So we get that the integral, or the area, is 0.179 units squared. Now you might say, well, with this, that's kind of hard. I don't have that on my calculator. And that's because you've got a slightly older calculator, but it's nothing to worry about. So instead what we do is and for those that have the new calculator, you can stop watching now. So in this case, we go to our third function, y3, and what we do, first of all, is we go options and then numeric. Hang on. So let's just get into that. So options, numeric, so it's F5, and we pick F1, which is absolute value, and then we exit out of that twice, and then we go y1 take y2. Now it doesn't matter which way around you do it, but as long as you do the subtraction of the two, and then I'm going to turn off both these by unselecting them, and then I'm going to draw that. And so I get that function there, and I only really want to worry about the region between 0 and 1. So we'll just do that, and then draw it, and do a zoom auto. So this is the absolute value of my function, and it doesn't care which one is a greater or less one, it's just going to give us the basic area. And so then we go Shift G solve, we go across, and we go F3, and we pick the normal integral one, and we go between 0 and 1, and we get this value of 0.179. So in this case, this also gives us the value, so that's through use of the absolute value. So I'll just record that on the notes. So you'll see that there, and perhaps I'll just add in the absolute value of y1 take y2, and that won't care, that will give us the area between the two. Okay, and that's the end of the lesson.